The bell has rung, class is in session. Today we're going to dive into why we find it so hard to say no to certain foods and uncover the psychological and biological roots behind those cravings. In our previous videos we learned about glucose, our primary fuel, and cortisol, which manages our safety and affects our nervous system. Today's topic takes us straight to the command center, dopamine. Think back to last night. How did you end up seeing the bottom of that bag of chips? Was it because you were truly hungry? Or did you feel defenseless and unable to stop? Why is it that you can't seem to stop yourself from finishing a bag of chips, but you'd never accidentally eat a whole kilogram of apples? The answer is the dopamine trap. This battle isn't happening on your plate or in your kitchen. It's happening in your brain's reward center. By the end of this lesson, those impulses will no longer rule you because you'll finally have the reins in your hands. If you're ready, let's begin. Often, when you finish a whole bar of chocolate in one sitting, you feel like you lack willpower. But let me share a scientific fact with you. Neuroscience research shows that your brain makes the decision to consume that food exactly 200 milliseconds before you are even aware of it. You are simply carrying out a decision your brain has already made. In our modern world, it feels like our willpower doesn't stand a chance. This is because the food industry understands the biological workings of the reward pathway perfectly, and they've designed their products to exploit it. We have a path in our brain called the mesolimbic pathway. This pathway evolved to reward our ancestors with a sense of vital joy whenever they found high-calorie, fat, and sugar foods in a world of scarcity. Back then, finding sugar or fat was incredibly rare. When that energy was found, the brain would secrete dopamine in an area called the VTA, ventral tegmental area. Then it would code that food into its memory to ensure it was never forgotten. It whispered, "Don't forget this, find it again." It is crucial to understand one distinction here. While dopamine is commonly known as the happiness hormone, it is not actually a hormone of pleasure. It is a hormone of wanting. It is a neurotransmitter that sends messages between nerve cells and serves as the primary chemical messenger for the reward and motivation system. In science, this is known as incentive salience. Our brains still function as they did in those ancient times, but we now live in a digital age. Finding sugar used to be a rare success. Today we achieve that success every single day. We used to have an internal navigation system working to make sure we didn't forget where the energy was. Now, in the modern world, that navigation system is broken. Let's look at how that happened. Why can an apple stop us but a processed food cannot? This reveals the biggest secret of modern food engineers. The bliss point. This is the specific mathematical ratio of salt, sugar, and fat that creates an explosion of flavor. This ratio is so precisely tuned that it actually causes the brain to forget to send the "I'm full" signal. And why is there always room for dessert even when you're stuffed? That comes down to a concept called sensory-specific satiety. Because of this mechanism, your brain's satiety signal is bypassed. You've eaten a massive meal and you are physically full, yet you still want dessert. This is because even if the brain is bored or satiated with the main course, it switches to a search for a new taste, sugar. At that moment, the dopamine response resets. This is no longer a matter of willpower. Hyperpalatable foods are literally manipulating your brain. These events continue as a chain reaction, even if we don't notice. Let's look at the links. We compared glucose to a roller coaster and explained that cortisol is a secret sugar factory. In moments of stress, cortisol rises, the brain becomes hypersensitive, and blood sugar drops, what we call the glucose crash. The brain then seeks an urgent reward for survival, and that's where dopamine steps in. When this trio comes together, willpower inevitably weakens. The reason you crave chocolate or chips instead of vegetables when you're stressed isn't a character flaw. It's a hormonal dance. In the front of our brain we have the prefrontal cortex, the decider, and in the inner part we have the striatum, which manages impulses. When dopamine spikes, the forebrain, the decision-making mechanism, becomes temporarily paralyzed. The brain goes into self-protection mode and reduces the number of receptors. We call this downregulation. During downregulation, because dopamine receptors have decreased, you no longer act to feel pleasure. You act just to feel normal. Activities that used to make you happy, like a walk or watching your favorite show, now feel boring. A cycle begins. The more you eat, the more you want to eat. But the pleasure you derive decreases because the brain can no longer hear the signal over the noise of high sugar and fat. This is exactly where addiction takes place. So, if addiction has occurred, are we stuck forever? Absolutely not. Our brains are manageable. Through the power of neuroplasticity, the brain can heal itself. By staying away from processed foods, we can clean our receptors. The 21-day rule isn't a myth. It's a biological reality. Staying away will be difficult at first, but the body will adapt. During this time, your palate will reset, your dopamine receptors will become sensitive again, and you will begin to taste real food. You'll return your brain to its factory settings. You'll notice that even a regular apple starts to taste different, much sweeter and more vibrant. I want to mention 2 more factors that affect dopamine. The first is sleep. Sleep is a magnificent process for the body's renewal, but I'm talking about quality sleep. Being asleep between 2300 hours and 3 o'clock is vital. Research shows that a sleep-deprived brain reacts 24% more intensely to high-calorie foods. When the body doesn't get enough quality sleep, it shuts the logic gates of the prefrontal cortex. The second factor is our microbiota. As you know, the gut is our second brain. I value the gut microbiota immensely, and we will dive into this in detail another day. For now, I'll just say this: certain bacteria in the gut must feed on sugar to survive, and they can send signals to the brain to get it. The cleaner our gut microbiota is, the better we can prevent this. That sudden, fake sugar craving might not be coming from you. It might be an order from the bacteria in your gut. We can take back the reins by reducing refined sugar and feeding healthy bacteria with fiber and fermented foods. Now for today's homework. The next time you have an intense craving for an unhealthy food, pick that food up and just look at it before you eat it. Try to be mindful of yourself. Ask, am I making this decision or are my hormones? Am I stressed, angry? Or did I sleep too little last night? Or perhaps you just want it, which is also okay. We can have cravings for no reason at all. This 10-second pause is a beautiful way to start managing the brain. I'll be waiting for your results in the comments. Class dismissed.